Welcome to In Depth with Academia. I'm Richard Price, founder and CEO of academia.edu, and today we're diving into a really fascinating, almost mind-bending question that you probably haven't pondered since you looked up at the stars as a kid and wondered what time even is. We're exploring the paper, A Re-Evaluation of Time Measurement Toward a Gravity-Independent Universal Time Framework by John W. Rogers. Now, as always, my goal here is to share what the research presents. So I'm not endorsing it, I'm not against it, just laying it out for you to think about for yourself. So what's the big question at the heart of this paper? Basically, is it possible to have a way of measuring time that doesn't get thrown off by gravity and motion? And is our current way of keeping time really giving us the full universal picture? John W. Rogers says, maybe not. If that sets your head spinning, you're not alone. See, right now, international time standards are based on atomic clocks. These are super precise devices that tick based on the vibrations of atoms, usually cesium or rubidium. But those atoms, turns out, are influenced by gravity. Einstein's theories tell us that time literally slows down if you're closer to a big gravitational field. That's not just a fun fact, but actually something that's been measured using atomic clocks on airplanes or mountains. You might be thinking, so what? Does that matter for me? Think of your GPS. Those satellites have to account for both special and general relativity, or else your phone would send you hiking into a lake instead of a coffee shop. But here's where it gets wild. If all of our measuring sticks for time get affected by little changes in gravity and speed, then is any measurement of time truly universal? Rogers suggests, maybe not. He argues that if we want a way to synchronize clocks, or meetings, or honestly anything, across the whole cosmos, we need something that doesn't care about local gravity, velocity, or what atoms you're using. If you're in a tiny spaceship zipping around a black hole and I'm chilling on my balcony, our clocks could tick at different rates because of general relativity, but why should time itself relocate just because we're in different places? Let's dig into some of the key points from the paper. First up, Rogers talks about the theory. Right now, every clock, no matter how fancy, is made of, stuff, matter, and matter gets pushed around, stretched, or slowed by gravity and motion. So an atomic second isn't fixed across the universe. It's kind of like measuring distance with a rubber band. Sometimes the band stretches, sometimes it shrinks, depending on where you are or how fast you're moving. To fix that, Rogers floats the idea of a universal time, a time that's the same everywhere, unaffected by gravity, untouched by motion, almost like a backdrop to reality. He suggests investigating timekeeping methods that break free from our matter-based tick-tocks, maybe something based on quantum entanglement, or using the cosmic microwave background, the radio noise left over from the Big Bang, or even, bear with me, a clock based on human consciousness. Since, our minds seem to experience now in a weirdly consistent way, regardless of where we are. And that's a fun detour, isn't it? Like, have you ever sat on a plane and felt like time drags even though the clock says otherwise? Or tried meditating and lost sense of time completely? I mean, does that mean your perception is more real than the clock's? Wild stuff. But again, I'm not saying that's how it works. It's just something the paper talks about, and I don't know, it sort of makes you appreciate the mystery. Back to the main argument. Rogers offers a thought experiment. Imagine two friends, one on Earth and one zooming away in a spaceship at near light speed. If they had some kind of magical, instantaneous telepathic chat, they'd keep right on talking in sync, no matter how much their clocks disagreed. Wouldn't that mean there's a kind of universal time underneath it all, a time not warped by gravity or speed? Interesting question, but to be clear, physics today doesn't actually let us build this kind of timekeeping system, so it's speculative, maybe more philosophy than engineering right now. Of course, Rogers points out, he's not saying relativity is wrong. He just thinks it might only apply to how time interacts with matter and energy, not time as a deeper thing in itself. That's a tricky distinction, and critics might say we just don't have any evidence for a gravity-immune timekeeper. Fair point. Rogers admits that, so, keep some skepticism handy. So what does this mean for you as a listener? Well, it's another reminder that science is always evolving, always open to new questions. Time, as weird as it sounds, is still up for debate. The research suggests maybe in the future we'll think of time differently, and maybe that will lead to better navigation, more accurate communication, or even cooler sci-fi tech. Who knows? For now, just remember, no one has the final word. Academic papers aren't dogma, they're invitations to wonder, to investigate, to ask what if. Thanks for joining me today on In Depth with Academia. I'm Richard Price, not endorsing, not refuting, just sharing. Until next time, keep asking, keep exploring, and try not to lose track of time.